then you get a nice little countdown, right? 3, 2, 1. Yeah, nobody with a little clapper though, right, to sync the sound. All right, review of functions, graphs of 6 basic functions when using a graphic display calculator. Is the first and last time we'll refer to it like that, right? GDC. To graph functions, it's important to choose appropriate window settings and to label the graphs correctly. For example, the graph of y equals square root x is shown below using 2 different settings. Okay, what's better, the left or the right? The right one, right? I mean, you're filling the grid. So the idea is, I'd like to fill the grid, I'd like to see everything. Like, there's nothing over here. Well, there is there. There's nothing over here, right? There are no, you can't take the square root of a negative, so why bother showing negative numbers, right? It doesn't make sense. Okay, so you really want to kind of look at the domain and the range of the function. Well, it's only zeros. And here's the other thing. What's the square root of 10? Well, it's a little bigger than 3, right? Because 3 squared is 9, so the square root of 10 is a little bigger than 3. So why would I go up to 10 when it's only 3, right? Why not go up to like 2? And this just took it to 3. Okay, so you can adjust the window to set. So explain why the settings on the right are more appropriate for this particular function. You know, show the or use the entire grid to show the function, let's say. Use the entire grid, or entire window, to show the function. All of that will be recorded for posterity. Graph each of the following with let's call it a graphing calculator. Choose appropriate, so pull out your graphing calculator. I didn't know you need to bring a calculator first. Record the window settings used in the format. Okay, so this is the setting. You'll see this on the formula sheet. I have copies of the formula sheet for you too. So I'm going to give you a souvenir copy of the formula sheet. It's kind of actually blown up a little. And basically it's the same formula sheet you're going to get on the diploma. This one will be yours to keep, so you can put your name on it. You can also write stuff down, like what is, like this is this, or also know this. For tests, if needed, you'll get a blank formula sheet. Okay, so one that's not written, but you'll get yours. Just get used to it, right? So you see, these are the formulas I have, and these are the formulas I don't have. Okay, so if there's something I need to know, I might write that in, and then as soon as the exam starts, you can pull to the formula sheet and just write stuff in if you want to on that. Anyways, this is the notation. They use x colon, then x min, x max, and x scale, right? Which is just running down the window of the calculator if you have a TI. And then same for the y. Okay, so we're going to record the window settings, sketch the graph, label the axes with appropriate variable, and scale the axes to match the window settings. Label the x and y intercepts, the asymptotes, and any other important features. Where appropriate, write the equation or equations of all asymptotes. Anybody know what an asymptote is? Okay, we'll get there. And state the domain and range using appropriate notation. Okay, so we're going to pull up a graphing calculator. I have the color one. That apparently doesn't work. Really? Okay. This is where we pause. Okay, so in your calculator, you're going to type y equals. And we're going to type y equals x. X. And we're going to hit graph. So, you know, this is at the standard window. The standard window is -10 to 10, -10 to 10, right? And anytime you just put something in, start there. Then figure out, oh, you know, I need to adjust. In this case, I don't need to adjust. Okay, graph goes through. So my window is -10 to 10 by 1s and -10 to 10 by 1s. My graph looks like. Okay, graph looks like this. There are arrows on both ends just because it does keep going in both directions. What's the domain? So what x values can I put in for y equals x? Or are there any x values I can't put in? You say, no, there are none. What? Wait. So you can put in any value for x, right? There's no restriction on the x. So it's a set of all x such that x belongs to the reals. Okay, that's a more formal domain notation. That might be what you see on the diploma, right? They give you a little more formal one, and we're gonna, after this, kind of be more informal. What about the y's, the range? Any values of y that you're not gonna get? Well, if I get any value of x and y is x, then I'll get any value of y. So that's read the set of. You've got these brace brackets, they mean set. This is important because see LR-B up there? Set notation. Set. So you got to learn brace bracket means set. Not for this, then for that. The set of what? X. What about the x? The vertical bar means such that. So that is read the set of all x such that x belongs to the reals. Okay, so that's how you read that. The set of all x such that x belongs to the reals. So if you want to write that down at the bottom, it says the set of all x such that x belongs to the reals. That would be fine. Okay. Questions on y equals x? No, easy. Y equals x squared. Okay, back to the calculator. Go here, square that, squared. Graph. Okay, should I adjust the window? Yeah, right, because x squared has to be positive, right? You square a number, you get a positive number. Okay, so now, what's 10 squared? 100, thank you. I'm just going to wait for somebody to answer. So, I don't necessarily want to go from negative 10 to 10, right? So let's say we go from negative 5 to 5. And you can go by ones, right? That'll put 10 ticks, okay, which is fine. Your scale doesn't really matter. If you get the scale wrong, you're just going to see a fuzzy axis because it'll plot too many points. It's not a big deal. It just means you can't count it. So 0 is the lowest I can get with x squared. And what's 5 squared? 25. Okay. Now I'm not going to go by ones. I'll go by fives, right? Okay. X res, you never touch anything below y scale. Okay. Never. Okay. That all just stays the way it is. You don't even see some of this anyways on your calculator. You graph. Oh, that looks nice, right? Fills the entire grid. Okay, it's good. It's a good graph. Okay, so what are we doing? Negative 5 to positive 5 by 1s, and 0 to 25 by 5s. Now, I do want little ticky things here, right? So you could go 10, negative 10, 10, negative 10. You go 0, 5, negative 5, 25, right? So a little labeling on the axis just kind of give us some sense of proportion, right? And if they don't label them, you've still got the window setting, so you could label it yourself, right? You could say, oh, it's negative 5 to positive 5. What's the domain of this? Okay, is there any number that you cannot square? Can I square negative 1,012? Can I square negative 2? Can I square 2? Can I square pi? Yeah, you can square any number. So what's the domain? Okay, there's a lazy way of writing it, right? X belongs to the reals. No set stuff. Okay, so as far as I'm concerned, when you're writing domain and range, you can just write x belongs to the real. You don't have to do the whole set of x such that, right? And what about the y values? What's the lowest y value? 0. Is there any high y value? Any upper limit? No. Okay, so what's the range? Can y be equal to 0? How do you get y to be equal to 0? What do you set x to? 0, right? 0 squared is 0. So y is greater than or equal to 0, right? You can just say that. Y is greater than or equal to 0. They might do this. Okay, so they might, I think they throw set brackets around it. I don't think they get any more formal than that. But it was a while since I looked at the exam and I can't remember. So, We're going to look at one exam. There's a released exam online. They released the January 2013 exam, which is the very first exam written. That's actually what this is. This is the January 2013 exam. Okay, so it's available on. We're going to sit down towards the end of the course. We're going to go through it together, right? Every single question. And the average on it was about 56-58%, right? Now, we're going to go through it, and you're going to say, how did I get like 56-58? That was easy, right? I don't know. Y equals x cubed. It's because they didn't read the question. You got to read the question. Okay, so let's go change the 2 to a 3. 3. No, wait. No, okay. You know what? Let's zoom 6, right? So go back to the standard. I should have gone back to the standard window first. Good starting point. All right, so that's decent, but I should probably tighten up on the x's, right? So you think we're cubing a number. This is going to 10. What's 2 cubed? 2 times 2 times 2? 8. Okay, so, all right. So we're going to stick to, maybe we go out to 3, but 3 cubed is like, what's 3 cubed? 27. All right, so let's do the window here. Let's go -3 to 3 by 1s, right? Because that's only 6 things. It says stuff up there. Never noticed that. Y min. Was there negative? Yeah, I went down, right? Okay, so let's go -30 to 30 by what? Sure, 5 sounds good. I'm going to be answering all the questions. Okay. And it's a little steeper before, right? Because we just had it really narrowed in, so that's what it looks, okay. That's what a cubic looks like. You have to know this. Okay. Those 3 that we've done now, you have to know these. Okay. We're going to look at it in more detail, but these are the 3 you're responsible for. Linear, nobody's ever going to ask you linear, it's too simple, right? Quadratic and cubic. Okay. That's what fits into here, our f-n, right? Graphs of polynomials. However, I'll still ask you about 4th degree because I can. So -3 to 3 by 1s and -30 to 30 by 5s. Okay, now there's going to be arrows on there. Okay, that's going to be 3, that's going to be -3, that's going to be -30, that's going to be 30. Domain. Any values that actually cannot cube. Now, what can't you do with x? You can't take the square root of a negative. Okay. So you don't see a root sign, and there's no restriction there. Also, you can't divide by what? 0. Okay. So if you don't see a radical sign, right, square root sign, and if you don't see an x on the bottom, then there are no restrictions on x. Okay. Keep that in mind. So this is x belongs to the reals. What about the y values? Start down there and go up there. Forever in both directions. So what's y? Real numbers, right? Any real number. Here's now, you know, the degree 1, right? Degree 1, exponent of 1, and the degree 3 have the same domain and range. Degree 2, on the other hand, has a different range because you're squaring things. So if you're giving it negative, it's giving you back positive. You cube something or you take something, if it's negative, put a negative in for x, you get a negative out for y. You cube a negative number, what do you get? A negative number, right? That's why you've got this going on. Okay, it's important. Radical, radical sign, right? What can't you have under a radical sign? Negative. So what's x going to be? It's going to be greater than or equal to 0. Right? So I can do that without graphing it, but let's graph it anyways. Okay, so first zoom standard, right? Let's go back to a standard window. Y equals, hello, y equals. Let's clear that. So if you just want, I just don't want to edit or way around that, so I'm just going to clear it, right? Root x. Well, that was good. Let's go back to y equals. Y equals square root second function. Yeah, square root. Now, some of you, maybe got like an older TI 80, maybe got an 83. Okay, so if you have 83s, things are going to look a whole lot different. Okay, if you have 84s, there might be a newer version of the firmware available, which will make things look like this or not. So we'll just work around that. I mean, occasionally I'll pull up a TI 83 or an 84. You're just going to get different windows and different ways of doing things, and you just have to figure out, for my calculator, this is how I do this. Okay, so this just stays under there, right? Y equals root x. Graph that. Oh, look, no negatives, right? Didn't we graph root x on the first page? So why don't we just use that window? Actually, let's go a little further. So let's go 0 to 10. You know what? Let's go to 16. What's the square root of 16? 4, right? Which means that I need to take this from 0 up to 4. Okay, cool. Right. Fill the whole window. Remember, fill the window. That's our goal. Okay, so that's square root, right? Going from 0 to 16. And as you can see, all 16 of these ticks. I generally try not to go more than about 20 ticks on the scale, right? Because then it just starts getting a little too close together. So, oops. Oops. Keep going left. 0 to 16 by 1s, and 0 to 4 by 1s. Okay, wait a sec. Okay, so that was 16, and this was 4, and that's y, and that's x. I don't think I labeled any of the other axes, but they're all x horizontal, y vertical. What's the range of this? Yeah, y is greater than or equal to 0, right? So the radical sign, that the root sign there, means the positive or principal square root. Right? So it means it's got to be a positive number. So that's greater than or equal to 0. What's the square root of 0? 0. That's good, right? Rational, y equals 1 over x. You're not really going to see much in the way of rationals. There are no rationals anywhere in there. Okay? So we're just doing this as an exercise in finding domain and range and just getting the shape of different graphs, right? Actually, not entirely true. No, actually not at all true. There are rationals in here. Equivalent rational expressions, all of this. Okay, never mind what I said. There's a ton of rationals, so you do have to know what a rational looks like. Okay, let's go back here. Let's take it out to the standard window. Y equals 1 over. So clear that and go 1 divided by x graph. Well, okay. That's kind of interesting. So the window seems good. The window doesn't look too bad. Negative 10 to 10 by 1s. Negative 10 to 10 by 1s. What did that look like? So it's got, like, the left-hand side is doing this. Right-hand side is doing this. That's 10, that's x, that's y, that's 10, that's negative 10, that's negative 10. Aha! Equations of the asymptotes. I think there's a little note there. Nope. Okay, here's what an asymptote is. It's a line a curve approaches but never touches. Okay. So in this case, this is the asymptote. You see how this curve goes down, but it's never going to reach there, right? Same thing there. Because what can't x be? What can't you divide by? 0. So you can't divide by, so x cannot equal 0. Right? Now that's actually going to be our domain. Now in this case, there's a really formal one, right? So the set of all x such that x cannot equal 0, but x belongs to the reals. Okay? You're not going to be responsible for writing it, especially not on a diploma, right? Because how much writing is there on the diploma? But as much as there was on this year's English, right? None. There's no written, right? It's 28 multiple choice, 12 numeric response. So you don't have to write anything. What's the range? So you notice we got this one going down all the way, right? So it says, well, you're going to hit all the negative y's. That guy's going up all the way. You're going to hit all the positive y. What value can't y be? What can't I make y? 0, right? So same deal, right? So let's go simple on this one. The range, y does not equal 0. Okay. The implication on any domains and ranges is that it belongs to the reals, and here you go. Y can't be 0, but it belongs to the reals. Okay. Equation of the asymptote. So the line the curve approaches but does not touch. This is a vertical line with the equation x equals 0. Okay. That's the equation of that line, right? Because what can't x be? Be 0. What happens as you get close to x? Well, you start getting really, really small values. And when you take 1 over a really small value, you get a really big value, and that's why it's shooting up. Okay? And if it's a really small negative value, like negative 1/100th, you take 1 over 100th, you get 100. You take 1 over 1/1,000,000th, you get 1,000,000. If they're negative, you get negative 100 and negative 1,000,000. Okay? You don't have to know that. Just a point of interest. Absolute value. We are absolutely never doing any absolute value. It's under math, and it's under num, and then there's ABS. Okay, so you hit that, gives you the bars. Okay, and then you put an X in there. So what the absolute value function says is whatever you give me, I'm going to give you back the same number, only it's going to be positive. So that means window, well, I don't need negative x's, or sorry, negative y's, right? So let's go 0. Okay, cool, scrap that. And there's the absolute value. Domain. X belongs to the reals. The range y is greater than or equal to 0. Okay, since it's an absolute value, it's just the magnitude, right? It's how big is this number, not what sign does it have. Negative 10 is 10 units big. Okay, we don't care that it's negative. Here's some graphs that we're going to learn about this semester. Sine x, that's that whole sinusoidal. Graphing calculator in degree mode, which we will never use, right? So your when it's cleared, it's going to be in radian mode. That's it. You never switch it to degrees, right? In 10 and 20, it was always make sure your calculator's in degree mode, and now it's never put your calculator in degree mode, right? So when they get cleared, they're good. You don't have to change anything. But for this, I'm going to set it to degree mode. Or not. Maybe I shouldn't. Whatever. And set your window from negative 360 to positive 360 by 90s, negative 1.5. So today we're really just interested in getting an idea. What does this thing look like? Oh, I better actually put a thing in there, right? Y equals, so clear. It's supposed to be sine x. Okay, that is the sinusoidal function. You will come to know this function fairly well. Not until, I don't know, sometime in April. What does that look like? Yeah, good enough. It's a wave, right? It's called a sine wave. Domain belongs to the real. Remember, the only time that x doesn't belong to the real when you have a radical sign, because you're not allowed to have a negative under the radical sign, or when you have an x in the denominator, because you're not allowed to divide by 0. Sine function doesn't have that. And the range, I'm going to give you this one. It's between -1 and 1. This is how we write it. We go -1 is less than or equal to y, which is less than or equal to 1. It's just a fancy way of saying the y values are between -1 and 1. Get more important as we do the sine function. Exponential, y equals 2 to the x. Exponential. That's here, here, also here, here. So there's 4 topics that deal with exponential. 1, 2, 3, 4. Resulted in 4 questions on the diploma. Okay. Now again, any of those numbers you see and try and narrow down, it's like 4 questions. That means it could be anywhere from 2 to 6. Okay. Like, that's not a set. Oh, there's going to be 4 of these. Okay, y equals 2 to the x. So let's go zoom standard again. You ain't going to see much when you do a sine function. Where y equals. If your calculator's graphing and you want to stop it, you realize, just hit the on key. Okay, that's a break. So if you see it graphing, it's like, oh my god, I entered the wrong thing. Just hit on. It'll stop it from graphing, and you can go change to what? 2 to the x. So let's clear that. 2 to the exponent. The upside down v here. Anybody know the name for the upside down v? Proper name? What Bugs Bunny likes to eat? It's called a caret. It's not spelled caret. It's C-A-R-A-T. Anyway, that's called a caret. Okay, and that's an upside down v. It means to the power of. So 2, you notice how it jumps up, right? When I did that, I want 2 to the power of x. So this time the variable is the exponent, right? We don't have 2 cubed, where the cubed is a number. We have 2 to the power x. Let's graph that, see what that looks like. So we're just kind of crawling along here, and now it seems to take off. Okay. That's not horrible. I'll leave that. I mean, yeah, we could change it a little, but I'm too late in the day. -10 to 10 by 1s. Oh wait, I guess we should change, because there's no negatives, right? All right, fine. So let's take the x down. -10 is fine. Let's go to maybe 5 and 0. Now this line here is an asymptote. That one. Because this curve will approach it, but it won't touch it, right? I cannot make that 0. Right? 2 to the power of something can never be equal to 0. I can get it really, really small by putting in a large negative x, right? Remember what a negative does? So I have 2 to the -10. That's 1 over 2 to the power of 10, which is 1 over 1,024, which is getting pretty small. Okay, so we're going, what, -10 to 5. And 0. So, oops. Y, x, y, 0. Okay, so this line is an asymptote. This is the line y equals 0, right? Because we're not going, there's no up or down, right? What's your y value on this line? 0, right? No up or down. Domain is x belongs to the reals, and the range is y is strictly greater than 0, right? You cannot make it equal to 0. So the range is y is greater than 0, must be greater than 0. Logarithmic. Logarithmic. Evaluating logs, laws of logs, solving problems with logs. We go 1, 2, 3. At least 3 logarithmic questions. Okay, so logarithmic, that's a unit that we're doing. Y equals log x. Anybody done chemistry? Where you use pH and you have pH is the negative log of whatever? You're going, What's this log thing? What'd your chemistry teacher? Just that button on the calculator. Just hit that button, right? Didn't explain to you what a log was. Well, we're going to learn what logs are. Okay, first, back to the window. Going to hit on, just break it, see it stopped. Go y equals, clear that. Here's your log key. It's very important, right? It's got its own key. Look, log. You don't get your own key unless you're important, right? Like sine, cos, tan. Graph. Wow, okay, what's this guy doing? So, I don't see it crossing over there. You can't see it here, but it is getting really close to that. It's another asymptote line. So what I'm going to do is, we can go out to 10, but this only goes up to about 2. So let's start at 0 to 10 by ones, and negative 10 is fine. Let's go up to about 2, maybe 3. Let's go 3. Okay, we can't see it, but it is going down here. So, what do we say? 0 to 10 by ones, and negative 10 to 3 by ones. Is that okay? No, wait, not quite that fast. Okay, that's 10, that's 3, that's negative 10. That's x, that's y. Asymptote, this is the asymptote line. What's the equation of this guy? Been there, done it. X equals 0, domain. X must be greater than 0. It's going to be strictly greater than. Okay, now we'll learn that when we look at logs. Why does x have to be greater than 0? Why can't it be negative or whatever? But it can't. And the range, y belongs to the reals, because we can see it going down here forever and coming up there. Functions and function notation. What better time to break than now? So let's say